Hi, and welcome to Math Week 1. This is a little video to help you understand the topics at hand. And basically, every week I plan on making a video about a math topic that I just learned. So basically, if this is in the future that you see this basically just going to help out anyone who finds this. And I really hope this is beneficial to anyone who doesn't understand these topics. And all of the topics are linked or in the next slide. So in this video, I will cover domain and range, integral notation, inequalities, and infinity. So I'm going to have multiple slides about each topic to fully help everyone understand the topics. So the first topic is domain and range. Domain, any line, set of points, function, or object on the coordinate plane. So basically the domain is x values. So just remember x values. And then range is any line, set points, function, or object on the coordinate plane. The range is the y values. So it's pretty much the same thing. A domain and range are very similar, except for range is y values and domain is x values. That is the difference. So basically, let's have an example so you don't get honestly confused, because when I first learned this, it was very confusing for me. But once I looked back at my notes and I started memorizing things, this will help you. So basically, what is the domain of 9, 1? Basically, the domain is 9 because 9 is the x value in this point on the coordinate plane. Basically, this is the x and this is the y. The y's range, the domain is x. So basically, this is probably a review for you, but you just have never heard of domain and range. So yeah, that is basically a little bit of it, but I will go more into it so you don't get confused. Okay, what is domain and range part 2? Domain is all the x values on a graph, so basically the horizontal spread. This really helped me remember because sometimes I get x and y on a grid confused. So this really helped me. And then all of the y values on a graph is the vertical spread. So basically, domain is left to right, horizontal like the horizon. Remember, the horizon is where the sunsets are, like where you look in the distance. And then the vertical spread is up and down. This is art class for me. I just remember those terms, the vertical, up and down on the grid. So let's have some examples to further have you help. So what is this point here? Okay, so basically this is -8 over 8. So your first step is really just to write out that. So I'm going to get a whiteboard and basically just write out what the point is. The point is -8, 8. And then my next step for that is to identify the x and y values, and then I'll find the domain and range from there. So the x values is -8 because that is how it is in the coordinate points, and then the y value is 8. So another way is just from left to right, where is it? Left to right, it's -8. And then from bottom to top, where is it? It's 8. So basically that's how it works for finding the domain. and range for a point. And so basically that's -8, 8. Let's find another example that might be less confusing. So basically your first step is to identify the points. So basically just get out graph paper or a whiteboard like I had before and just identify these 2 points, here and here, and then come back. Okay, so now that you identified the points, they're -6, 4, and 3, -4. So another thing is you always have these brackets here and your answers when listed out coordinates in this case. So that's just how the rules are. And then identify the domain and range. So find the x and y values in this situation. Then you just identify the domain and range. So the domain of the situation is -6 and 3, and then the range of the situation is 4 and -4, because on the y-axis this is -4, this is 4, and on the x-axis this is -6, and this is 3. There's multiple ways to write out the domain and range. Writing out points. When writing out points, it can be represented in a table or a list. Remember, domains x on the left and range is y values, also known as fx, on the right. We can also represent points on a graph. We have all 3 examples of writing out points. Now, all we have to do is find the domain and range, find the x and y values from these examples. There's also maps that are similar to tables except they have arrows pointing from the domain to the range. The domain of all 4 examples, the table, the list, the map, and the graph, are here. -6, -3, 5, 2, and 10 are all of the x values, which is the domain in this. And you can also find it on here. If the x values are here, x values from the graph, you can further go and find the x values. And the fx or y values for the range are 5, 5, 1, 7, and 10. Types of graphs. So there's 2 different types of graphs. There's the discrete graphs. So basically the points on a graph are not connected. In other words, they're scattered across the graph, like some of the examples I showed you before, with all the points scattered. Continuous graphs is a graph that has one smooth curve on it. Also, all of the points are connected to each other. So this can be a line or like this example, and those are the different types of graphs. So let's get into interval notation and inequality notation. Now, this first slide may confuse you, but I will definitely go more in depth in the slides to come. Interval notation is like so, and the inequality notation is like this. So basically, we have brackets and parentheses across the domain and range. So this really does sound confusing, looks confusing, but I'll get more in detail later. And basically, the differences between these two is parenthesis equals the less than symbol here, and the bracket equals the less than or equal to symbol here. So let's get more into it. Interval notation. So the first step is to find the domain and range of the 2 points. find the x values furthest to the left and right, and find the y values downmost and topmost. So the domain is -6, 5. So you can see it's -6 and 5 here on the x-axis. And for the y-axis, it's -4 and it's 6. And basically, when should you use the symbols? So when doing interval notation, the closed dots are the brackets, or this thing that looks like a box. And the open dots are parentheses. So the only other time we use parentheses is when we have infinity, which I will go over later. But yeah, this is how interval notation works. It's just writing out the points from the different types of things on the coordinate plane. So let's go over inequality notation. So it's basically the same steps, except for it's written out different. And this one, in my opinion, is harder to learn and harder to understand, but once you get the hang of it, it's a lot better. So like interval notation, you have to find the domain and range of the 2 points. So find the x values for this to the left and right. Find the y values downmost, and topmost. So basically, here is a open circle. So one should use the symbols. So doing inequalities, closed dots are less than or equal to, and open dots are less than symbols. The only other time we use less than is when we have infinity. Like, it's basically the same thing, except for it's brackets and parentheses, but this one is less than or less than equal to. So basically, it's -8 is the domain of this front on the furthest to the left. And because it's an open circle, we have the less than symbol. And then the one that's furthest to the right for the domain is 5. And because it has a closed point, it is less than or equal to. And then same for the range, the y value on the downmost, make sure you do bottom first, is -2, and because it's open circle again, it's less than symbol. And then it's less than or equal to for 6 up here. So you might be confused why there's an x and y value. So as you know, range is y and domain is x, and just this is how it's set up. So here is a helpful hint that I personally think is awfully helpful. So when trying to find the inequalities or interval notation, you can add a box around the object to find the furthest points, furthest to the left and right domain, and downmost point and topmost point is range. So as you can see, this is a box around, and then finding the points from bottom to top, to left to right. So domain, I'm using interval notation because it is easier, it is shorter, but both are correct. So this is -6. Okay, so the range of this situation is -7.75, and then the second part of the range is 6.5. So that is a helpful hint, and now let's finally get into infinity. For infinity, any line, set, or point, function, or object on the coordinate plane that goes past the visible graph or has arrows means it is infinity. So this looks confusing at first glance, but don't worry, it is not as confusing as it seems. So basically, if it has an arrow leading up or down or left or right. It just means that it goes on forever. And then this doesn't even have to be a straight line. It could be a curved line. It could be really anything. But basically, the point that isn't a point that's an arrow is just going to be infinity. So for domain, furthest to the left is positive infinity, and the furthest to the right is negative infinity, while the range is the opposite, where from bottom it's negative infinity, and to top for the y-axis is infinity. So that is infinity. So overall, you should have learned from this video what domain and range is, how we can represent domain and range, the difference between discrete and continuous graphs, the difference between open and closed dots, what interval notation and inequality notation is, and finally all about inequalities for domain and range. I mean, infinities for domain and range. I really hoped you liked this video. I hope it was helpful, and I really can't wait to make more videos like this.